Hello everyone, welcome back. This is Engineer Hussein Mwasabi. So in this video, we'll be looking at viscosity in terms of fluid study. Alright, so before we begin, do not forget to like and subscribe to the channel. So what does it mean when we say viscosity or dynamic viscosity? So by definition, viscosity is defined to be the tendency of a fluid to resist shearing stresses. Other books could say the resistance offered to a layer of a fluid when it moves over another layer of a fluid, or rather a non-fluid. Viscosity is due to the cohesion and molecular momentum exchange. So if you basically want to understand viscosity, you have to bring in the idea of cohesion and interaction between particles. But what am I trying to say? All right, let's try and visualize this. Let's take, for instance, in other words, we have, let's say, a fixed layer. Let's call this a fixed layer. And we have another layer on top, which is the upper layer, which is the movable layer. This is the fixed one, like that. If we consider a section here, call this x, and we study the fluid in this section. Now, the distance from the fixed layer to the upper layer is dy, because it's a change in depth. And we understand that we will have a certain force applied on the upper plate, which is regarded to be the shear stress, or the shear force rather, like that. Now, what we need to understand is this, that when the two layers of the fluid which we have, the upper layer and the bottom layer, which are separated by distance dy, moves one over the other at different velocities, the viscosity together with the relative velocity, which we have here, which is the velocity final, which is just V max, causes a shear stress acting between the layers. So what I'm trying to say is that the top layer causes a shear stress on the adjacent lower layer, while the lower layer as well causes a shear stress on the adjacent top layer. This shear stress is proportional to the rate of change of velocity with respect to the depth which we have, which is dy. If we consider a velocity profile, in a case where we're having, let me just use a simple sketch. Let's say we have something like that. So let's say that this is y and this is u. If I consider a small change in y and u, say we have that and that basically. So let's call this du and let's call this dy. So if we consider a small change in y and u, we end up getting the velocity gradient. So we end up getting the velocity gradient, which is du over dy. This is basically the velocity gradient. Other books can call it the rate of shear stress or shear deformation. The other thing you need to understand is that the shear stress is directly proportional to the velocity gradient. This means that if we say that the shear stress is directly proportional to the velocity gradient, then we're saying that we have this in context. Now, since these are variations, we need to expect the constant of variation. But in our case, we'll say the shear stress is equal to mu du over dy, where mu is basically the constant of proportionality, and this constant of proportionality is called the coefficient of dynamic viscosity, or basically just only the coefficient of viscosity. Now, with this in mind, I need you to understand that the viscosity can be thought of as the ability of the fluids to resist continuous deformation due to what? A shear stress. Now, if the dynamic viscosity is mu, then it's up to us to make mu the subject of the formula. Now we're having shear stress being equal to mu times the velocity gradient, which is du over dy. Now I know some of you might be wondering what the shear stress symbol really is. This shear stress symbol is called tau. So at this point, making mu the subject of the formula, all we have to do is multiply the entire equation such that we'll have dy by du multiplying everything, and we have mu being equal to tau times dy over du, and this will give us what we call as the coefficient of viscosity, or the coefficient of dynamic viscosity. Now, what are the units? The units are Newton second per meter squared. Now, if at all you want to find your answer in poise, you need to know that 1 poise is equal to 1/10 Newton second per meter squared. In other words, to convert whatever you have into poise, all you just have to do is to multiply what you're having by 10 to get your poise in Newton second per what? Meter squared. So the next thing we need to know is the kinematic viscosity. By definition, it's defined to be the ratio of the dynamic viscosity to the mass density of the fluid. So, kinematic viscosity is equal to the fluid dynamic viscosity, which is mu, divided by the mass density of the fluid, where we know that mu is the dynamic viscosity and rho is the mass density. The units for the kinematic viscosity are meter squared per second. But if at all you need to convert in stocks, be mindful that 1 stock is equal to 10 to the minus 4 meter squared per second. So if you have a value in meter squared per second and you need to convert it to stock, just multiply that value by 10 to the 4th. And the opposite would be 10 to the minus 4 to get the opposite dimension. All right. Pointers I would highlight in this video is that if you remember correctly, in my previous explanation, There was a part where I did make mention that the shear stress in a flowing liquid is direct proportional to the what? Velocity gradient. Or the shear stress rather is just direct proportional to the what? Velocity gradient. Du over dy. Now this concept is called the Newtonian's law of viscosity. Or just Newton's law of what? Viscosity. So this is just Newton's law of viscosity. All right. If you have any queries, you can reach out to me on WhatsApp on the line +260 77 149 5252. All right. Remember, slow progress is better than no progress. Let's strategize before becoming a statistic. Try and push for that A plus.